And let's finish with a review by going numbers 35 to 40. Says find the standard form of the equation of the ellipse with the given characteristics. So if we have a center at the origin and the major vertices are right and left 5 and the foci are right and left 3, if it helps to sketch a picture, that's fine, but you still should be able to see that it is horizontally oriented. A, again, is the distance from the center to the major vertex, so that's going to be 5. So A squared is 25. The foci are 3 away, so that means C is 3, so C squared is 9. And then I don't care how you do it, if you use A squared equals B squared plus C squared, or the other one, C squared equals A squared minus B squared. Somehow find that B squared is 16. Once we do that, because the center is at the origin, you know it's going to be x squared over something plus y squared over something equals 1. Because it's horizontally oriented, A squared goes underneath the x, B squared goes underneath the y. (36) Center at the origin. So again, if it helps, our minor vertices are at 8 and -8. That's the minor. So therefore, we are positioned vertically with foci up at 10 and down at -10. I'm going to do a lowercase m for the minor vertices, capital M if we had to for the major ones. And so I should be able to tell that our major vertices are going to be further than 10 away. Foci are always inside the ellipse. So we are vertically oriented. Just write vertical for now. Our B is going to be 8. So B squared is 64. Our C is 10. So C squared is 100. And again, however you want to do it, we should be able to get that A squared is 164. Centered at the origin. A squared, we're vertically oriented, so the larger number, 164, goes underneath the y. The B squared goes underneath the x. All right, major vertices, 2, 0, 2, 6, minor vertices, 1, 3, and 3, 3. We should be able to see that we are oriented. If our major vertices are 2, 0, and 2, 6, that means we are vertically oriented. Now, as far as our center, it's always exactly halfway between the major or the minor vertices, however you want to do it. Either way, we should be able to see that it's going to be 2, 3. Therefore, from the center to a major vertex is 3. So A squared is 9. From the center to a minor vertex, from 2, 3 to 1, 3 is 1. So B squared is 1. And I don't even need C squared here. Okay. If our center is 2, 3, that means I'm going to have an x minus 2 squared plus y minus 3 squared equals a 1. And all I need, because we're vertical, I need a larger number underneath the y and a smaller number underneath the x. I'm not going to require it, but I think it would be good to show your proficiency to not write a denominator of 1 in your final answer. All right, foci 0, 0 and 4, 0. So again, if you just think about that, 0, 0, 4, 0, that means our major axis is horizontal. So we are horizontally aligned. Now, major axis, if the major axis has a length of 6, that means that 2a, because remember, a is the distance from the center to a major vertex. So the whole axis is 6, that's 2 a's. So a is 3. So a squared is 9. Foci are, let's see here. I need the center first of all, so let's do that. Center is going to be at the midpoint of the foci, so that's 2, 0. So that means B is going to be Well, let's see, we'll do the foci. So we'll do C first. We're not going to be able to get B directly. So C is 2 away. So C squared is 4. From that, we're able to get B squared is 5. So our equation is x minus 2 squared plus, I'm going to write this as y minus 0, but I'm not going to write the minus 0, squared equals 1. We're horizontal, so 9 goes underneath the x, 5 under the y. Now 39, I'm just going to jump right in and say, because we have the center, I know it's x minus 2 squared plus y minus negative 1 squared. We're going to have an equals 1 over there. I do want to go ahead and just kind of get an idea of what's going to happen here. So 2, negative 1 is my center. 2, 1/2.
May I have your attention? The middle school team meeting is beginning now in room 104.
Is a major vertex. So right there, I know that we are oriented vertically. So right there, I know my A value is 1.5 or 3/2. So a squared is 9/4. And since we're vertically oriented, that 9/4 goes underneath the y. For the same reason in the number 38, we had a major axis of length 6. If a minor axis is length 6, that means 2b is 6. So b is 3, b squared would be 9. There's our equation. And number 40, our vertices, and again, unless explicitly said otherwise, these are considered to be major vertices. So if they're at 5, 0, and 5, 12, 5, 0 would be here, 5, 12 would be here. We can again see that this is vertical. Our center is going to be halfway between those, so it'll be at 5, 6. The distance from that center to one of those endpoints is 6, so a squared is 36. Now the endpoints of the minor axis, this is just a fancy way of saying the minor vertices. So from the center, 5, 6 to 0, 6 or 10, 6 is a distance of 5. And we're all set. X minus 5 squared plus y minus 6 squared equals 1. So we're vertical. 36 goes underneath the y. 25 goes underneath the x. And that is it for the review. I wish you guys the best of luck.